Hello everyone, welcome to William Talk Physics channels. William Talk Physics easy. Today, we are going to discuss on subtopic about Kirchhoff rules. There are two rules on Kirchhoff rules. The first rule states that the sum of current in is equal to sum of current out. Then, for the second rules, state that sum of the potential difference for closed loop is equal to 0. So, how do we identify the positive sign and negative sign of the potential difference in the closed loop? For battery, if the loop direction is same as the EMF direction of the battery, then positive sign of potential difference will be obtained. Whereas, for the loop direction that is opposite to the EMF direction of the battery, we will get negative sign of potential difference. Then, for the resistor, we consider the loop direction and the current direction that pass through the resistor. When the loop direction is same as the current direction that pass through the resistor, negative sign of potential difference we will get. In other words, positive sign of the voltage will we get when the loop direction is opposite to the current directions that pass through the resistor. So, how we going to identify the loop directions? There are two. The first one is we follow the EMF direction of the batteries in the singles loop. The second one is we follow the EMF directions of the battery with the greater watts in the singles loop. So, now we're going to see some questions. For this question provided, question given that the EMF for there are three batteries. For the first one battery is 4 watts, and the second one is 6 watt, and the third one is 5 watt. Then there are three resistors. The first one is 15 ohm, and the second one is 13 ohm, and the third one is 18 ohm. So they are going to two loops, two single loops, separated. So the first one is what directions? The first one is clockwise direction, since we follow the EMF with greater watt, and the second loop direction is clockwise also, because we follow the EMF direction of the battery with greater watts. Alright, we already identified two loop directions, the loop 1 and the second loop. So, by applying the Kirchhoff's first rule, which is current in sum is equal to the sum of current out. So, the current in is I1 plus I2, and the current out is I3. Subsequently, we can form an equation. I1 plus I2 equal to I3. Then the first equation is I1 plus I2 minus I3 equal to 0. Alright. Then, for the Kirchhoff rules, which is the Kirchhoff second rules, sum of the closed loop, which is the loop 1 and the loop 2, is equal to 0. By applying the method that we identify the voltage sign, we can form an equation. For the loop 1, we can start either from a point. I start from here. So, the loop direction is clockwise. So, loop direction and EMF direction is same. So, we will get the positive 6 plus with the current's direction and the loop direction is opposite, which is opposite. So, the voltage or the potential difference of the resistor 1 is equal to positive also, positive I1, because the direction of I1 is here, and the direction of I2 is here, and subsequently the direction of current 3, the third current, is flowed as such directions. Then, for the potential difference for the first battery is opposite with the loop direction. The EMF direction is opposite to the loop direction, so we'll get -4. And the last one for this loop 1 is for the second resistor. As the loop directions is same as the current directions of the resistor 2, so we will get negative 13i2 equal to 0. Then we will form the second equation, which is the 15i1 minus 13i2 is equal to negative 2. Then for the second loop, which apply the same Kirchhoff second rules, we start either point. I start from here, the battery, the third battery. Since the EMF directions is same as the loop directions, we get positive 5. Then for the third resistor, the direction of currents that pass through the third resistor is same as the loop directions of the second loop, so we'll get negative 18i3. Then for the first battery, the loop direction is same as the EMF direction, so we'll get positive 4 watts. Then for the last resistor of the loop 2 is the first resistor. The current that passed through the first resistor is same as the loop of the direction, so we will get positive 15s. Sorry, oops, it's negative 15s. Then we can construct a third equation, which is 15i1 plus 18i3 is equal to 9. Then by substituting these three equations into the calculator, we'll get the variables, which is the I1 is equal to 0.116 ampere, current 2 is equal to 0.288 ampere, and for the third current is equal to 0.403 ampere. Okay, let's look to the second equations. So same, by applying the same method that we just now discussed on the first questions, direction of loop 1 is follow the EMF direction of the higher voltage battery, so it will be clockwise. And the second loop also, we will get the loop direction is anti-clockwise, since we follow the only EMF directions of the battery in the single loop, which is the battery Q. Alright, first equations, sum of I in is equal to sum of I out, so IP and IQ is the current in, IP plus IQ is equal to the current out, which is IR. So we can form the first equation, which is IP plus IQ minus IR equal to 0. Then for the Kirchhoff rule, Kirchhoff second rules, for the loop 1s, we start from the point of battery P. Since the EMF directions of the battery P is opposite to the loop direction, so we will get negative 1.3 watts. Then for the resistor P, the current direction, which is the IP that flow like these directions, is opposite with the loop directions, so we will get positive 2 IP. Then for the resistor Q, the current directions that pass through the resistor Q is same as the loop directions of the loop 1s, so we will get negative 0.8 ohm IQ. Then for the battery Q, the EMF directions which flow like this is same as the loop directions of loop 1, so we get 1.5 watts. So can construct second equations. So for the second loop, we start from battery Q. The EMF directions we flow from negative charge to the positive charge is same as the loop direction, so we get positive 1.5 watts. Okay. For the second loops, we start from the resistor Q. Okay, the current directions which flow in these directions is same as the loop directions, so we get 0.8 IQ plus with, when the battery Q EMF directions is same flip from the negative charge to the positive charge, we will get 1.5 volts with positive sign, because the EMF direction of battery Q is same as the loop direction of loop 2. So then for the resistor, which is stated as the capital R, the current directions is same as the loop direction, so we'll get negative 4 IR. So we can construct the third equation and we get the final answer. Then see the third questions. For the third questions, the circuits look complicated a bit, but it's okay. By using the methods that just now I taught, we will find this subtopic is very easy. Okay, Kirchhoff first rule. So there are three currents, which is the current 0.8 and the current 1.2A, and the third current is doesn't have the value, so we put as I. So we label this as I2 and this one is I1. So the I ins is equal to the total of I out. So the I in is I1 plus I2, and the current out is I3, which is value I. So we can construct the equations. I1 plus I2 equal to I3 and substitute into the value. 1.2 plus 0.8 equal to I, and we will get the value of I, which is the third current, and the value is 2 ampere. Then for the loop 1, the loop 1 directions is we follow the higher voltage battery EMF directions, which is the 10 voltage battery, and the EMF direction is flow from negative to the positive. So the loop direction is anti-clockwise. Then for the loop 2 directions, since we doesn't know the EMF directions of the unstated voltage battery, so we use the 8 watts, which is the higher watts in these single loops. So the loop direction is clockwise for the loop 2. So for loop 1, using the Kirchhoff's second rules, we start from the 10 watt battery. EMF direction is same as the loop direction, so we get positive 10V. And for the 12 ohm resistor, the current's direction is same as the EMF, it's same as the loop direction, so we'll get negative 12 I2, which is also the I2 is 0.8 amperes, so 0.8 times with 12. Then for the 5 watt batteries, the EMF direction is opposite with the loop direction, so we get negative 5. And for the 8 watt battery, EMF direction is same as the loop direction, so we get 8 positive sign. Then for the last, the resistor R, the currents that pass through the resistor R, which is the I2, is same as the loop directions, so we'll get negative 0.8 R equal to 0. Then we get the R value by using the max solving methods, and the R is 4.25 ohm. Then for the second loops, we start from the unknown voltage battery. Actually, you all can start from either point, it's same. So from this unknown voltage battery, the EMF directions is same as the loop direction, so we get positive EMF. Then for the resistor 2 ohm, the current directions that pass through the 2 ohm resistor is same as the loop direction, so we get negative 2 times with 1.2. Then for the 4 ohm resistor, is same. The current direction is opposite, is not opposite, is same. For the 4 ohm resistor, the current directions that pass through the 4 ohm resistor is same as the loop direction, so we get negative 1/2 times with 4 ohm. And for the 5-watt battery, the EMF direction is opposite with the loop direction, so we get -5. And for the 8-watt battery, EMF direction is same as the loop direction, so we get +8. Then we can find out the EMF value is actually 4.2 wattage. For this subtopic question, the question always asks about the unknown value of the currents, the resistor value, or the wattage of the battery value. Also, they will ask about the potential difference. The potential difference from a point to a point. So, for example, potential difference between A and B. So we'll start from the final point minus the initial point, which is the VB minus VA. Then for this type of question, he asks for the wattage or the potential difference between the S point to the T point. So we either can use this pathway to reach from S to T, or this way from S to T. So by substituting the equations by using the Kirchhoff rule, which is same, we start from Vs. From every point there are potential difference. So for S point, the potential difference is Vs. Okay, for finding the potential difference between the S to T, I use this pathway instead of this. You all can use this also. Both also can. Then, for the first that I pass through is the 8-watt battery. The directions of I pass through is same as the EMF direction, so I get +8. Then for the resistor is 4.25 ohm. The directions that I pass through is same as the current directions that pass through the resistor are. So I will get -0.8 ampere times with 4.25 ohm of the resistor R. Then the last that I pass through is 10-volt battery. The 10-volt battery EMF directions is same that as my pass-through direction, so I will get +10. Then I reach my final point, which is point T, and equal to the potential difference of point T. So by substituting the formulas, Vs minus Vt is also equal to Vst. So the Vst I get is -14.6 watts. Since the potential difference we can get in the positive sign, so the final answer is 14.6 wattage. Alright, there are a sample question that I'm going to ask you all. You all can try to do it. So by using the method that just now I taught, we identify the loop directions. Here is the loop 1 and the second loop. Then by applying the Kirchhoff first rule and the second rules, we're going to find out the value of the I3, I2, I1 through 3 equations that we're going to construct. And the final answer we will get is I1 equal to 1 ampere and I2 equal to 0.45 ampere, whereas the third current is 1.45 ampere. And the second question is find out the potential difference between P and Q. So we are going to have 3 pathways, which is the first pathway is flow like this, the second and the third. Okay, it's the end of today's videos. Thank you everyone. Don't forget to hit the like buttons and share this video to your friends. Also, don't forget to subscribe my channels to get my next video notifications. Thank you all. We'll see you all in the next video.